ammonium sulfate supplies a nitrogen, a very efficient form of nitrogen, together with sulfur in its form that is immediately available for roots to take it up. Crops need both nitrogen and sulfur to build their amino acids and protein and for chlorophyll formation. So having both delivered together in ammonium sulfate really amplifies the benefit of these nutrients. There's a big difference between elemental sulfur and ammonium sulfate, or sulfate-sulfur in ammonium sulfate. Sulfate is what the plants take up. So if you have elemental sulfur, whether it's from an elemental sulfur source per se, or the elemental sulfur you can find in sulfur-enriched fertilizers, sulfur-enriched phosphates, for example, if you have that, you will need a transformation from elemental to sulfate, which bacteria take care of that, so it's going to be influenced by environmental factors. And there's going to be a delay that could be weeks or months, depending on the conditions. Temperature plays a big role. Colder temperatures are going to slow it down. Particle size, the finer the particle size, the faster it's going to take place. But if that particles are granulated into a bigger particle, then it will counteract the otherwise higher surface area that you gain with the finer particles. Additionally, moisture is needed because it's needed for the bacteria to take care of that oxidation. And placement method is going to play a role. Surface applications limit the surface area, so it's going to be slowing down that oxidation process. The bottom line is that it is extremely helpful to give the crop what it needs. Sulfate sulfur is what the plants, the roots are going to take up, is what's immediately available, and sulfate ammonium sulfate does precisely that. From a crop production point of view, sulfate ammonium sulfate has really been in the market for over 50 years. On the other hand, gypsum traditionally has been mostly a soil amendment for sodic soils, for soil reclamation. From a handling point of view, you have, in the case of ammonium sulfate, a very soluble source. In the case of gypsum, is only slightly soluble, so particle size becomes critical. It has to be really fine, which has the handling issues as the drawback. Also, if you look at it from the companion ion point of view, in the case of ammonium sulfate, that's nitrogen, which in very rare occasions there's sufficient nitrogen in the soil for optimal yields. Whereas in the case of gypsum, the companion ion is calcium, which most soils, they have plenty of calcium available. So in most soils, you're just contributing with the sulfur when you apply the gypsum. In a nutshell, with 24 units of sulfur and 21 guaranteed units of nitrogen, sulfate ammonium sulfate is a high analysis fertilizer offering 45 units of essential plant nutrient in every 100 units of product. Gypsum, by contrast, contains only 17 units of sulfur, and the rest of it, the analysis is calcium, which in the majority of crop acres could really be considered a filler, having little impact on crop yield. The size of fertilizer is very important, and it has to do with ballistics. The size and density of a granule is going to determine how fast and far it will be thrown from a fertilizer spreader. So when blending fertilizers, it is important to choose granules that are roughly equivalent in order to allow for a thorough blending. The goal is to avoid segregation of the different components within a blend so that each nutrient is applied uniform across the field.